Hello everyone. In this lecture, we are going to discussing about the complementary shear stress. In the previous lecture, we discussed the shear stress is the which act as a parallel to the surface of the body. So let us consider a infinitely small block of ABCD and applying the shear stress parallel to the surface of the BD. So it is as shown in the figure. So then we have to draw a free body diagram of the block ABCD. And here we have to observe that one. So reaction force which is equal amount of the applied shear stress tau and in opposite direction, and also it is act on a plane AC. Now the question is, block is in equilibrium condition. So many students we have to say that one. So yes sir, it is in the equilibrium condition. So why mean we are applying the shear stress tau and reaction force it is generated equal amount of the tau and it is in opposite direction. So the block is in equilibrium condition. But answer is no. So block is not in equilibrium condition. So why means, what do you mean by equilibrium condition? So it is the summation of the forces and also summation of the momentum is 0. Here summation of the forces are 0. So plus tau and minus of tau. So both are in the opposite direction. So summation of the forces is 0. But what about the momentum? So here we have to observe that one. The forces tau acting at a plane BD and plane at AC at the distances of the AB and CD. So which act as and which form a couple in the clockwise direction. So these shear stresses it will produce a couple in the direction of the clockwise direction. So due to this couple there is a tendency to rotate the block in clockwise direction. So then to attain equilibrium condition, so only a couple is applied in a such a way that it has the tendency to rotate in block in clockwise direction. To maintain the equilibrium condition, we should once again have to rotate in the anti-clockwise direction when we are applying the stresses on the block. So this can be we have to achieved by the applying and having the shear stress intensity tau on the faces of the AB and CD. See here I have to observe that one. So here we are applying the stress tau on the plane BD. So equal reaction also it will be generated at face AC. So it is a forming a couple and it will be chance to rotate the in the clockwise direction. So here to maintain the equilibrium condition we have to rotate the block in anti-clockwise direction. Then only this block will come to equilibrium condition. To achieve this one, here also we are applying the shear stresses we are applying in the faces of the AB and CD faces. Let us consider thickness of the block is unit, so which is perpendicular to the figure. So here we are considering the thickness of the block is unit, so which means let us consider thickness is the 1. Then next we have to go into calculating about the moment of a given couple. So here we are going to calculating about the momentum due to the applied shear stress, so which parallel to the face BD. So we know that one the momentum is force into perpendicular distance or maybe the force into lever R. So here we are applying the shear stress, that is the tau. So we know the stress, then how to determine the force? Force is nothing but stress into the area. So here we are applying the stress is the tau, shear stress we are applying tau and area of the block into lever diagonal, that is will represent the momentum of given couple. And area of the block is it should be width into thickness. Here we are considering thickness is the unit. Let us consider thickness is the 1. Then width into thickness is the area of the block. So width is the BD. So BD into thickness is the 1. So area of the block is BD. So now momentum of given couple, which is equal to tau into BD into perpendicular distance. The perpendicular distance, which is the AB. So this is the momentum of a given couple. Similarly, next we have to calculate the momentum of balancing couple. So here, maintaining the equilibrium condition, we are applying the shear stresses on the faces of the AB and CD. Then we have to calculate the momentum due to this balancing shear stresses. That is, we have to calculate the momentum of balancing couple. So which is equal to force into lever arm. So we know that when the force equal to applied shear stress, that is the tau dash into area of the block. So area of the block is thickness into, so width. Here width is the AB. So thickness is unit. Let us consider 1. So area of the block will become the AB. So momentum of balancing couple, which is equal to tau dash into AB into perpendicular distance. The perpendicular distance is, for this one, this is the perpendicular distance, that is the BD. So BD. So then we have to equating these two, then we are maintaining the equilibrium condition. Then we have to equating these two momentums, momentum of a given couple and also momentum of the balancing couple. So which will become the tau BD AB equal to the tau dash AB BD. So here BD BD will get cancelled, and also similarly AB AB also will be cancelled. Then finally tau equal to the tau dash. This tau dash we are calling as the complementary shear stress, which is equal to the applied shear stress. Then rule of the complementary shear stress is, a shear stress in a given direction cannot be exist without balancing of equal intensity in a direction at right angles to it. So this is we are calling as the complementary shear stress. To maintain the equilibrium condition, same amount of the shear stress we are applying, so in the direction of the right angle to the applied shear stress. Thank you.